Hello everybody and welcome to Algo Expert. In this video, I'll be covering the question of generate document. Now before we dive in, let's make sure we understand what the question's asking of us and the input and output structure. So for this question, we're going to be given two inputs. The first input is going to be a string. This is called characters. The next input will also be a string, and this is called document. Now what we're being asked to do is look at all of the characters in our characters string and determine with those characters if we can create the document string. So you can kind of treat the document as our target. You can treat the characters as what's available to us. And what we're being asked to do is return true if we are able to generate this document using those characters, and return false if we are not able to. So for this sample input right here, we are able to create the string Algo Expert is the best using the characters given in this string. Now, just for the sake of an example, if I were to remove this capital B right here, we would not be able to create this document string because we do not have a capital B. Now, just as one more example here, if I were to remove one of these T's, so let's just remove the one right there, we now would not be able to create this document string because we do not have enough T's in our characters string to use to create the document. So that is how this problem works. Now, a few small details to go through here. The characters in your character string, and in your document string for that matter, can be anything. So they could be letters, they could be special characters, they could be numbers, they could be uppercase letters. You could be given anything, so keep that in mind. Spaces are also characters that you want to look out for. So for example, here we actually have 1, 2, and 3 spaces in this character string, and you do require those spaces to create this document string, because here we have 1, 2, and 3 spaces. So if we were given this input for our characters, but it didn't contain any spaces, then we would not be able to create this document string because this document string has 3 spaces. So I will leave underscores here representing that these are spaces, but you could also be given underscores. So just to make this clear, this is a space. I'm just writing this in so that you can actually see that there is indeed a space here. So that is pretty much all I need to cover. Now let's talk about how we can solve this problem. So as we start talking about how we can solve this, I will start by stating that there's multiple ways to solve this problem. In fact, in this video, I will show you 3 different ways. Now, this is a very popular problem when it comes to coding interviews, and the reason for that is there's many different approaches, but one of them is much more optimal than the other. So you have to be very careful how you're implementing these solutions, because there is a lot of ways to make a very poor time complexity algorithm. And if you were in a coding interview and you were given something that was considered to be an easy question like this, then you would want to make sure you're going with the most optimal approach that you possibly can. So I will start by showing you the non-optimal solutions. They're also important to understand. And then finally, once we get to our third solution, I will show you the most optimal way to do this. So with that said, let's get into solution 1. So the first and easiest way to solve this problem is to loop through all of the characters in our document string, count how many times this character that we're currently on occurs in the string, then count how many times it occurs in the characters string, and see if these occurrences are valid. So what I mean by that is pretty much if we have enough characters in our characters list, so the count of the character in our characters list is greater than or equal to how many is in our document. So as a very basic example, let's say we started here on the very first character. This is a character that is a capital A. So what we would do is we would then look in the document string and count how many times this capital A character occurs. Now we're going to see that this actually leads us to 1, but we obviously don't know how many times it occurs until we look through the entire string. So we see we have a count of 1. So then what we would do is we would then look through the characters string and we would count how many times capital A occurs in there. So we see that A is here. This is the only occurrence, and so it occurs once. So since the number of times it occurs in the characters list is greater than or equal to the number of times it occurs in our document string, and sorry, I said characters list, I meant string. Since that is valid, that means that we can indeed create the character A, or we have enough uppercase A's. So now what we need to do is move on to the next element. So if we move over to element 2 here, which is an L, we do the same thing. We count how many times an L occurs in this string. We see that this is only going to occur 1 time. And then we look in this character string. We count how many times the L occurs. We see that this only occurs 1 time right there. So we do the comparison. We see that we have enough L's. And then we move on to the next character. So I'll go through a few of them and then we'll kind of speed up. But as we move over to G here, we see that G occurs exactly 1 time. So what we do is we then count inside of our character string and see how many times G occurs. We see that this occurs 1 time, and so we are good. We can create this G. Now, it's worth noting that if there was multiple G's in this character string, that would be totally fine. If we have more characters, that's great. We don't need them, but it also means that we still can create the string because we have more characters than we need. So what we have to do is loop through every single one of the characters in our document string and count how many times it occurs in the characters string. So if we get to the very end of our string and there was no conflicts, we were able to create all of these characters, we had enough, then we can just return true. But if at any point in time we are looking through this document string and we see that we don't have enough characters in our character string for whatever character we've just counted, then we return false and we say, nope, we cannot create this document. So that's as easy as solution 1 is. But what I want you to notice with this approach is that we're going to count the same character multiple times. So for example, when I come here to character E, when I'm on E, I need to look through this string and count how many times it occurs. So I see that lowercase e, not uppercase e, occurs 1, and then it occurs 2 and 3 times. So it occurs a total of 3 times. So I count that, then I come in here and I count how many times E occurs in this string starting from the beginning. So I see 1, 2, and then 3. So we are good, we have enough E's. So then we move on to the next character. So we would imagine we would move over to R, and then eventually what's gonna happen is we're gonna come back here to this E character. So we're gonna hit E again. Now we're on this character, and we have no way of knowing that we already counted this character, at least with this implementation, and so what we do is the exact same thing. We loop through this string, we count how many times E occurs, we see that E occurs 3 times, we then check again in this character's string how many times E occurs, we see it occurs 3 times, we do the comparison, and we see it's good for a second time. And then again, when we get over here to this E, we're going to count it one more time, right? So you get the idea. This is not a very efficient algorithm. We're repeating a lot of work. And in fact, this solution right here is going to run in big O of M times and then N plus M time. Now, M is the length of our document, so I'll just write kind of an M under here, and N is the length of our characters. So both of these strings, that's the length of them. Now, the reason we get M multiplied by N plus M is because M times we have to do N plus M work. What I mean by that is we are going to loop through this document. So that alone is going to take us M time, just to loop through every single character in the document. Then, every time we loop through this document, we're going to have a character, right? So we have some character. We're going to count that character in not only the document string, but in the character string as well. So that means that we need to take N plus M time to count both how many characters are in the characters list and how many are in the document list. So at every iteration of our document, which we go up to M, we do N plus M work, because to count in a string, or to count the occurrences of something in a string, we need to look through the entire string. So that is why we get M multiplied by N plus N. However, we do get constant space. So this is the time complexity, so big O of M multiplied by N plus M, and then we have constant space because we don't use any external space. So this is a very inefficient algorithm for the reason I stated, that we're repeating a lot of work. So ideally, we don't want to count the same character multiple times. If we've already counted it once and we've determined that we have enough of it, there's no reason to count it a second, third, fourth, and potentially infinite amount of times, especially if we had a lot of repeated characters in our string. Imagine we were given an input like this, A, right? Just a bunch of A's. And then maybe our characters list had something like, B, 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 whatever. You get the idea. If we have a lot of repeated characters, that means we're going to be counting this character a ton of times repeatedly. Whereas if we only had to count it once, that would drastically reduce the time complexity of our algorithm. So with that said, let's move on to solution 2, and let's see how we can optimize this approach. So solution 2 is identical to solution 1, except we're going to keep track of the characters that we've already counted. So everything that I said in solution 1 holds for solution 2, except now we have one extra step. That step is, at the beginning of our algorithm, we're going to create some set. So let's just call this counted, like that. And we'll make this equal to an empty set to start. Then, throughout our algorithm, after we count one of the characters, we will add that character into our counted set. Then if we ever reach that character again, so we ever see that one more time, then we just skip it. There's no need to count it again because we already counted it. That's as easy as the second solution is. So if we're on character A here in our document, we go through and we count again and we count again. And then what we do is we add A into this counted set. So now we know if we ever see another uppercase A, we don't need to count it. Then we move over to L, we count it in both of these, we check if there's enough. If there is, we add it in here. And obviously, if at any point there's not enough characters, so the count doesn't match up, or there's not enough, we just return false. So we add L in, and let's actually just get to what happens when we go to E, because that's the most interesting one. So now we're on E. We would add E into the set, and there would be a bunch of other elements in the set as well that we would have counted beforehand. So then, when we eventually reach E again, all we need to do is check, is E in this set? We see that it is in this set, so rather than counting characters and document again, we just move on to the next element, because we know there's no reason to count it again. Now, I will just mention the space. This is going to work the exact same as all of our other characters, but just make sure that you don't implement some type of solution that treats spaces differently. So we would have to count our spaces, but same thing here. When we count our space, we would add it into this data structure. So we would just say, space, that's not an underscore, that's meant to represent a space. And then whenever we reach this second space here, we just wouldn't count it because we've already counted it. So that's all we're doing for solution 2. This is actually really going to improve our time complexity, but it's going to add a bit of a space complexity. So let me show you what I mean. Our time complexity is going to be big O of C multiplied by n plus m. So we have not removed the step where we need to count all of the occurrences of a character in both the characters in document list. We do need to do that, but we only need to do that C times. Now, what does C stand for? Well, C is the number of unique characters that are in our document. So C is almost always going to be less than M, because you remember our last time complexity was M multiplied by N plus N. So this is really going to increase or better our time complexity. And the reason for that is if we have duplicated characters, which in a large document we're almost guaranteed to have. In fact, any document that's larger than the number of characters we have on our keyboard or the number of total characters there could possibly be is going to guarantee that there will be duplicated characters, means that we are now only going to count those one time. So that really drastically betters our time complexity of this algorithm. So just keep that in mind, that this is much better than solution 1, even though it may not look like that because it looks very similar. But C will almost always be much smaller than M. And again, remember, if we had this string, say like A, right? So let's say we had 4 A's. If we were in our previous algorithm, then our time complexity, if we were just writing out the numbers, would be something like, 4, because 4 was M. So M is equal to this. Let's just say that. We can say N is equal to, and let's just make it the same thing. So A. We would have 4, which is the length of M, multiplied by, and then N plus M. So N was 4 plus 4. So what that would end up giving us is 4 multiplied by 8, and that would be equal to 32, right? So that would be how many steps we would have to perform in the previous algorithm. Whereas here, now if we use C, the number of unique characters in our document is only 1. So now, rather than having 32, we're going to have 1 multiplied by 4 plus 4, which is going to give us 8 steps. So we've drastically reduced the number of steps that we need to take by simply implementing this set here that keeps track of the characters that we've already counted. So now let's move on to solution 3, which is going to be an even better time complexity. So even though solution 2 was much better than solution 1, we still can do better. In fact, the solution I'm going to show you now runs in n plus m time. It does not have any constant being multiplied by n plus m. So in the previous 2 solutions, you probably realized that we were looping through the document, right? And then as we looped through the document, every single iteration, we then looped through the document again, and we looped through the characters again. Now that led to a lot of repeated loops through the same thing. Why are we looping through the document and the characters multiple times? Why don't we only loop through them one time? In fact, why don't we loop through the document or the characters, we can pick which one, and while we loop through, count every single character. Rather than counting the same character potentially multiple times or looping through it a ton of different times, why don't we just loop through it once, store the count of all of the characters, and then see if we have enough of those characters to create our document. In fact, that's exactly what we're going to do here. If you're confused, don't worry, I'll go through this in depth. But the idea here is we're going to use a hash table, a hash map, a dictionary, whatever you want to refer to it as, that is a key value store. So I'm going to write out a little dictionary or map at the top of my screen. And what this map is going to hold is, as the key value, it's going to have a character. Obviously, it's not going to be more than one letter. I'm just writing char, so you get the idea that's what the key is. And then the value associated with that is going to be how many times this character occurs. So 3 would tell us that char, again, I know this is not an actual character, but let's imagine this was one character, occurred 3 times. So we're going to start by looping through either our characters or our document string. It doesn't matter which one you pick. In fact, there's an argument to be made on why you would pick each one to loop through to start, but it doesn't matter. You can pick either one that you would like. And then you are going to count how many times one of the characters, or I guess, sorry, all of the characters occurs in this string. So let me just show you what I mean, and we're going to loop through the character string to do this. So we'll start here at B. Now, the steps here to count how many times these characters occurs is going to be the following. We're just going to check if this character occurs in our hash map or in our table. And in fact, let's just call this count, means that's equal to, and then an empty hash map, dictionary, whatever. So we're going to check if this character right here occurs in this map. Now, if it does, all we have to do is add 1 to whatever the value of that key is. So if we had a uppercase B here, and this was equal to say 1, then all we would have to do is just change this to be 2, because now B, well, it occurs 2 times. Now, if it is not in there, then all we do is we add the character in, and we have a value of 1, because it occurred 1 time. So that's what we do when we add B. Now we come to S, so we will add S into the table or hash map or whatever. It's going to have a value of 1. We then come to T. We're going to add T in here, so T is going to go to 1, and we will add E. I'm going to run out of space, but you get the idea. We have E, that's going to be 1. And let's kind of skip forward a bit. Let's imagine we add all of the other ones that occur 1 time. Now we hit E again. All right, so we hit E. We see now that E is in this hash table. So all we do is we change this 1 to be equal to 2. And then we continue. We would see the next E right here. We would now change this to be equal to 3. And that's all we have to do. So at the end of this first step, where we loop through our characters and we count all of the occurrences of characters, we'll have a populated counts, hash table, dictionary, whatever. And now all we need to do is loop through our document and check if the counts here correspond with how many times characters occur here. But this time, what we're going to do is rather than adding to this data structure when we find a character, we're going to subtract from it. So we're going to do the following. We're going to loop through our document, and we're going to start by checking if the character occurs in the counts data structure. Now, if the character that we're on does not exist in this data structure, all that means is that we cannot create the document because we found a character that just didn't occur in the characters list, and so we return false. But if it does occur in this data structure, then what we need to do is change the key of that character to be -1. So subtract 1 from it. So let's say we have A here. We would have uppercase A, and this is equal to 1. As soon as I see this A, what I'm going to do is subtract 1 from this and change this to 0. So now I'm saying we've used one of these A's. So let's remove one of them from this data structure. That's what this is saying. Then we would come to L. We would do the same thing. We would subtract 1 from it in the data structure. So let's just do the example with E's because this is the best. When we're on E, the very first E, we're going to see this 3. We see it does exist. And so we make this a 2. Now that this is a 2, we can continue going forward. We go through all the other elements like we normally would. Then we see this other E. Now we're at the second E, so we subtract 1. This becomes 1. Then we make our way over to this last E. And again, we would go through all these other elements. I'm just skipping them for this explanation. And finally, we change this to 0. So let's say that when we get to this last E, in fact, let me tack on one more E here at the end of the string. So now we finish that last E. We go through these ones. Now we're on this E. So now we reach this E. We check if it exists in the counts. It does exist in the counts. So what we do, though, is we check if the value here is greater than 1, or if it's greater than or equal to 1, so greater than 0. Now, if E has 0 as the key, that means that we've used all of the E's from our character string already. So that means we cannot create this document because there's not another one here for us to use. So we just return false. And that's as easy as this solution is. So that's what we're going to do. Loop through the characters list, create this data structure that stores the counts, then loop through our document, subtract from the counts, again, imagining that we're kind of saying, hey, we used one of these characters, so let's remove it or let's decrement it. Then at the very end of our algorithm, we see if we made it all the way through the document. If we did, we return true. And if at any point in time we see a key that has 0, or we see that an element does not exist in our counts data structure, we return false. So this solution is going to take big O of n plus m time, and this is going to have a space complexity of big O of c. Now, the reason we get n plus m is because we need to loop through the character string 1 time, which I believe I called n. Maybe this one was m. I forget which one I've called which, but you get the idea. And then document, we need to loop through this 1 time as well. So we get n plus m. And again, I totally forget if this is an m and this is an n. It doesn't make a difference because it's still going to be n plus m. You get the idea. We need to loop through character string one time. We need to loop through document string one time. So since we're looping through both of them, that's n plus m. Then we have C space. Now C again is the number of unique characters, but this time it's the number of unique characters in our characters string. Now the reason it's in our character string is because that's what we're counting, right? We're counting the character string. Now if you decided to, you could count the document string to start. So you could do this in the reverse order. You could count the document string and then you could count the character string. You'd have to change the implementation a little bit, but you can pick which one you want to count first of all. Now, since we decided to count the characters string first, we have OC space, where C is the number of unique characters in the characters string. And the reason we have C space is because we have to have C keys in our data structure, storing all of the unique characters that were in this string. Now, I just want to emphasize one more time, if you were in a coding interview, it's very important that you discuss those previous solutions, but that you say the reason you're not going to use them is because something more optimal exists, and this is something that exists. Now, you may even want to ask your interviewer if it's okay if you use external space, because if they say no, then you would have to go with something like the first solution, right? So anyways, that is these three solutions. Now, let's implement them in the code walkthrough. So I'm here in my code editor, and I have my generate document function defined, which has two input parameters, the first called characters, the next called document. Now we've got three solutions to code out. I will start with the least optimal solution and go to the most optimal solution. So starting with solution one, we're going to say for character in and then document. So remember, this is the solution where we're going to be counting the frequency of characters in both the character string and the document string. I'm going to say that the document frequency is equal to, and then a function that we've yet to define. So count character frequency like that. And this function is going to take two input arguments. So character and document. So we want to count the frequency of this character in this document or in this string. Next, we're going to say that the characters frequency, let me spell frequency correctly, is equal to then count character frequency. We're going to pass again the character, but this time not the document. We're going to pass the characters string. So now what we want to do is compare these frequencies. So if the document frequency is greater than the character's frequency, then we return false because that means we do not have enough of this character to make this document. Otherwise, we return true. So now let's code out this function right here. So I'm actually going to copy this and I'm going to say define and then count character frequency. We're going to take in a character and a target string. Now what this function will do quite simply is return to us the frequency of this character in this target string. So I'm going to say frequency is equal to, and then 0. And then I'm going to say for char in target. And what we're going to do is check if this character is equal to the character we're looking for. So if char is equal to character, then frequency plus equals 1. And then we are going to return this frequency. So that's actually the entirety of solution one. Now I just want to note that I wrote out this function here, right, which will count the frequency of an element in a string, but there is oftentimes a lot of methods we could use that will do this for us. For example, in Python, we could write this. We could write document.count, and then we could count the character, right? Now this would do the exact same thing as this function, but don't be fooled. This still is going to take big O of n time. So this function takes big O of n time, where n is the length of the target string, but so does this .count method. This is kind of just showing you behind the scenes of what .count would do, and I just wanted to write this function out to make it very clear where we're getting this time complexity from, because this is going to take big O of n time, and we're doing that twice, so big O of n time and then big O of m time. I should have highlighted them in the other order because m is the length of our document, n is the length of our characters, but you get the idea. So that is solution one. Now, as a reminder, this solution runs in big O of, and then this is going to be m multiplied by n plus m time, and this takes big O of 1 or constant space. Again, m is the length of our document, and n is the length of our characters. We get this initial m from this for loop. We then get the n plus m from these two lines right here, where we are counting the character frequency. So with that said, let's move on to solution 2. I'm actually going to copy this entire thing, comment it out, and then paste it down here because solution 2 is very similar to solution 1. In solution 2, we're going to keep track of the characters that we have already counted and make sure we don't count them multiple times. So I'm going to start here by saying already counted is equal to, and then this is going to be an empty set. Then at the very top of my for loop, I'm going to check if the current character has been counted. So if the character is in already counted, then we can just continue. And then at the end of my for loop, I am going to say already counted dot add, then not character's frequency, sorry, character. So this is actually the entirety of solution 2. This solution is going to run in big O of C multiplied by n plus m time, and it's going to take big O of C space, where C is the number of unique characters in our document. Now we just made this set. We're just adding to this set every time we count a character, and then we're making sure that we're not counting the same character multiple times by skipping a character if we've already counted it. So that is solution 2. Let's comment this out and let's move on to solution 3. I'm just going to copy this function signature here so that I can paste it down here for the start of solution 3. So for solution 3, we actually cannot reuse a lot of that code because this is going to be much different. What we're going to do in solution 3 is we're going to count the frequency of characters in our characters string. We're then going to kind of compare that to what's in our document string. So we're going to start by saying that our character counts is equal to an empty hash map / dictionary. We're then going to loop through all of the characters in our characters string, and we're going to check if this character is not in this counts data structure. If it is not, we need to add it in. So if the character is not in the character counts, then we're going to say character counts at character is equal to 0. So we're just setting this default value equal to 0, adding this character into the data structure. Then we're going to say character counts, and then this is at index character plus equals 1. So let's say that it was actually not in, I need to fix this typo here, so it was not in the character count. We would set it equal to 0, then we would immediately change it to 1. Whereas if it was already in there, we wouldn't execute this if statement here, or whatever is indented in this if statement. Instead, we would just increment the value by 1. All right, so we've now done that. We now have access to all of the frequencies of the unique characters in our characters string. Now we need to loop through our document. So for character in document, we're going to say if the character is not in the character counts, or the character counts at the character key is equal to 0, then we need to return false. And this should not be an if, this should be a return. So what this is checking is if the character does exist in this character count. So if it does not exist in this character count, it means we never saw the character that we're referencing in our document in our character string, and so we cannot create the document. But if it is in there, we need to make sure that it doesn't have a value of 0, because if it has a value of 0, that means, yes, this character existed, but we didn't have enough of it. So in that situation, we return false. Otherwise, what we do is we say the character counts at the character minus equals 1 to say that, hey, we've used this character now, so we need to subtract this value by 1. Then finally, at the end of our program, we return true. So if we do make it through this for loop and we don't return false, that means we can generate the document, and well, we return true. Now, as a reminder, this solution runs in big O of n plus m time, and this will take big O of C space, where again, C is the number of unique characters, actually this time in our character string, not in our document string. So that's a kind of differentiator between these two. Since we are looping through the characters and we're keeping track of all of the unique characters in our characters string, C now is based on our characters, not on our document. So hopefully that's clear, but that has been this code walkthrough and this Algo Expert question. So with that said, I hope you enjoyed, and I look forward to seeing you in another Algo Expert question.